Hello, guys. Welcome back. And today we're gonna start the chapter one, which is functions and relations. Actually, we've been touching on these chapters since term two in year 11, and we already did a couple, like for example, inverse functions, power functions, set notations, domain and range, and pace-wise defined functions, and so on. And also, we're going to learn some of the new stuff, which is called the even function and odd function. So also, we're going to understand about sum and a product, which is the functions, and to measuring the difference. Uh, Lastly, we're going to solve some problem. And in chapter 2 to 8, we're actually going to find the different familiars, the functions from chapter 2, which is we did linear functions. And chapter 4, we're going to do some polynomial functions. And chapter 5 and 6, we're going to do the exponentials and logarithms and circle functions. They all part of the functions. So let's getting start today's lesson actually. Uh, So first, beginning of the session, I actually write something about set notation and set numbers. Um, Actually, we know it's a set. So, what's a set means? It's a selection of the objects. So if you say a symbol like x belong to a, something like that, we could read as the number of set or belong to. As in, and so on. So we actually know how to do these kind of things. For example, 2 is an even number, so belong to the even number, as in the even number. And x is not an element of a, so which is we normally just a slash and belong to. So for example, 2 is not belong to odd number. And also, what's a subset? Subset actually means something is could be read as a content. So content in A, or we say the B containing A. For example, we say B, or we have a 0, 1, 2, and A is 0, 1, 2, 3, 4. So we say B inside of A, so we call subset. Yeah, also we can rewrite some Venn diagram, which is you're familiar with, which is like the elements common in between, which is we call the intersection. So the intersection we normally write as A intersection B, and that looks like denoted. And sometimes it is an independent, looks like A and B are no common elements. So we will say empty set. So which is going to be the empty, so or empty side. So we say A intersection B is empty. Yep. Couple of samples you actually need to know and familiar with the stuff. So you make sure you guys during the practice and know what they're actually representing. And then after that, we have something called in A or in B, so which is like a both. So union. So we say A and B are union, so which is all together in A and B. All right, let's start some examples, which is like example one. We need to rewrite about A and B. So we can say A have 1, 2, 3, 7, four numbers. B is 3, 4, 5, 6, 7, which is around like five numbers. So for this question, if we want to ask A and B, so we're actually gonna rewrite from 1, 2, 3, 4, 5, 6, and 7. So which is all numbers we have in A and B. And so what happens if I say A not B? So that means something called set difference, which is we're gonna touching on base later on. That means you had A but not in B. So which means like we had a 1, 2, 3, 7 have A, but we don't have in A is 4. Oh sorry, we don't have in in A but not in B. Sorry, A not in B. A not in B. So that actually is 1 and 2. Yeah, and if I say union, A union B, so that actually equal to A union B equal to 3 and 7, actually. That's pretty good. So we can say we have together, we have both the same numbers, and you can highlight it or circle it. That's all up to you guys. Okay, now as I said, set A not in B, so which is we call the elements in between. So the first question, the same idea is the A not in B, so equal to 1 and 2, right? So we have A as 1 and 2, but we don't have in B, so 1 and 2. So B is B not in A, so we actually equal to 5 and 6 and 4. So 4, 5, and 6. Perfect. All right, and something also gonna be very important for you guys to know what is natural number, integer number, rational number, and irrational numbers. So there's some couple of examples being mentioned. You can rewrite into your reference book and the bound reference, please. That will help you with the knowledge. And natural number actually be representing n, which is the all x in positive integer number, and integer number we say representing the z, so which is gonna be second smallest. A rational number is representing q, which is like a number from can writing as a fraction, and p and q have to be an integer in the beginning of the point. And then the real number is R, so you can say any numbers in the real life, irrational and rational number. So there's a circle in between. So we will describe the set. We can say 0 to 1 is all real number between 1 and 0, which is all the real number. Yeah, not including 0 and 1, okay? 2, x is greater than 3, which means the real number greater than 3 but also equal to 3. And x not equal to 0, that representing the any numbers but not except for the 0. And also this one 2n, that actually means all even natural number because it's belong to n. And 2n minus 1, that means odd number, which is natural number. Okay, so make sure you notice what's the interval notations. Okay, there you go. That's the difference in the intervals. We say, let's strip to the examples. We're gonna write the individual one of them. We use the plans. Okay, so first thing in A, so we start from negative 2 to 3. So that's a 0 in between. So you start from the dot to the dot. So that means you actually can equal to, okay? Make sure that's the dot point. A closed circle, we say. And sometimes you will say the B is like from negative 3 to 4. So you had a circle to, you don't have to write that big, by the way. So there's the open circle. That means you're not equal to, okay? Just in case. And last one is like the negative infinity. So we can rewrite as, that's a 3, which is you're gonna say um, negative infinity to the 3. So which is start from 3, open circle, and going to negative infinity. And that means the domain in the end, you can say something like domain or range when we when we draw the graph of functions and stuff, and you will learn this one again. Okay, this exercise actually this A1A. Okay, 1A. So you're allowed to do that. Any questions from here? Okay. That's for the 1A, which is the set notations and the set of numbers.